over a few things, and I want to talk about the binomial distribution. And I'm going to use Excel. Okay, we're not going to talk about theory. If you wanted to actually calculate what the probabilities were for the binomial distribution, why are we interested? Why is the binomial distribution so important? Well, you know, we dealt with probabilities where we discussed, well, let's say 10% of the population has diabetes. If I get two people, if I pick two people randomly, what's the probability both of them have diabetes? Hey, pretty simple, 0.1 times 0.1. What's the probability that neither one of them have diabetes? Hey, easy also, 0.9 times 0.9. Let's say I want to sample 25 people. What's the probability none of them had diabetes? 0.9 times 0.9 times 0.9. That's very entertaining, but it's almost never going to happen. What's the probability all of them had diabetes? Well, I know it's 0.1 times 1, but that's never the situation we're really working with. It's more likely that we sample 25 people, and we're concerned, you know, we only have supplies for 5 people. If we're going to have 25 people come to the clinic today, what's the probability that more than 5 of them are going to have diabetes? Well, that could be 6, that could be 7, that could be 8 out of 25. Much more complicated situation. Hence, you would have to really figure out that probability. You would have to use that really nasty looking formula with the factorials that we look with all the probabilities and the exponents, right? Pretty nasty, right? If you can imagine, in the demonstration in the lecture, you're using numbers like, you know, a sample of size of 4, and it's a probability of 2. What if it's a sample size of 25 and you're interested in 5 or more? It really get ugly. Those factorials really get ugly really quick, right? So in Excel, we can do that fairly simply. It has functions built in specifically for that purpose. And I'm going to open up Excel. Okay, good. And let's see, I'll move that over. Okay, so, let's say that we're working with diabetes, the prevalence of diabetes in this population, probability of having diabetes for any individual is 0.10. Okay, let's say I'll take that example I just talked about. The probability, let's see, I'm going to take a sample size of 25 people, and I want to know what the probability of exactly I'm going to pick a fairly, let's see what I would expect. Exactly 2 people having diabetes. Okay, sounds like a complicated process here, because it could be 1, well, it is exactly 2, but I want to know what the probability is. A little bit complicated to calculate. Well, we do have a function in Excel. It says equals binom dist, parentheses, okay? And let's see what it asks us for. And this is in the lecture. You heard similar terms to this. Number S, number of successes, number of people in that sample that satisfy that criteria. In other words, have diabetes. Comma, trials. That's the number of people in your sample. Is your number of trials. And the probability of any one individual having it is your probability of S. And then we have cumulative or true or false. In this case, it means something. Okay, so I'm going to put, let's see, binom dist, the number of successes. I'm interested in exactly 2 people. I want to know what's the probability of having exactly 2 people that have diabetes. Number of trials, what's our sample size? 25. What's our probability of any individual in this population having diabetes is 0.1. And now cumulative. Let's think about this for a second. Cumulative here means that number 2 out of 25 and everything below it. In other words, if I say true to cumulative, it's going to give me the probability of having 2 or fewer people. 2 people, 1 people, or no people. I didn't ask that. I asked just probability of exactly 2. So I'm going to put false. I'm going to close the parentheses, and the probability is 26%. That seems pretty high, doesn't it? Why is it so high? of having exactly 2 out of 25. What's the prevalence?
10%.
It's 10%. How many people do we sample? 25. How many would you expect to get most likely? 2.5, either 2 or 3. So it makes sense that 26% of the time you'd have exactly 2 people. Let's do something interesting. I'm going to say, what's the probability of having nobody that has diabetes? Well, one way to do that is 0.1 times 0.1 times 0.1 times. That's too laborious. I'm going to go over here and I'm going to say 0. I'm going to say 1, 2, 3, 4, 5, 6, 7, and I think that's enough for now. And in the column next to it, I'm going to say equals binom dist, parentheses, and I'm going to ask it to tell me, let's see, the number of successes. Instead of putting a number in there, I'm going to click in here. It's going to say the number 0. It's going to use 0. Comma, the number of trials is 25. Comma, the probability of someone having a probability of success is 0.1. Comma, I'm going to put false for cumulative. I only want the probability of having nobody that has diabetes. It's 7%. Okay? Not 0. There's a good chance, it's remember that it's only 10% prevalence. There's a chance that we'll get nobody that has diabetes. Well, how am I going to calculate it for one person? I'm going to do the same calculation here as I did there, except that instead of doing it manually, I'm going to copy the formula down, and it's going to do the same thing for each one of these different outcomes. Exactly 1 person out of 25, exactly 2 out of 25, and so on and so forth. And I'm going to go over here, and I'm going to say fill down. You could do this a number of ways. You can click on the corner and drag, and so on and so forth. I'm going to go up to Format, Cells, and Numbers, and I'm going to round this off to 1 decimal place, just to keep things, neat. Why did I make this a little smaller? Okay. No, wait, that's not good. That's not going to help us. Let's do this a little bit. Yeah, 3 decimal places. Okay. Okay. So these are the probabilities. For 2, exactly 2 people, probability is 0.26. 3 is 0.22, and so on and so forth. And you can see that around most of these are clustered around the mean. If I were to draw a graph of this, we would see a almost normal distribution with the mean being at 2.5. Remember we talked about in the lecture, the mean is going to be n, the sample size, times the probability, 2.5. And the standard deviation is going to be the square root of n times p, which is 0.1, times 1 minus p, which is 0.9. I'm not going to worry about that right now that much. What if I ask you, what's the probability of getting 2 or fewer people who have diabetes when we sampled 25 people? 2, what? Yeah, okay, I could do it 2 ways. One way is, I could say it's equal to the sum. You got ahead of me there. You cheated on me. You knew too much. I could just say sum of these 3 probabilities, because it's the sum of the probability of none out of 25, 1 out of 25, or 2 out of 25. Probably have 2 or fewer. On the other hand, I could have done it just the way you suggested, equals binom dist, parentheses, and what was I going to do there again? Let's see, get my little hint there. Numbers 2, comma, trials is 25, comma, probability is 0.1, comma, and this time cumulative is true. And we get the same thing. Okay, the reason why it's tail, I remember I rounded. That's why it's not that. What if I ask you, what's the probability of getting 3 or more people who have diabetes? How would you figure that? Exactly. In other words, that's going to be all of these people going all the way up to 25, right? Or a better way to do that would be just say it's equal to 1 minus the probability of having 2 or less. Okay, now you got to be a little bit careful with this, because every once in a while we'll try and cross you up on a word problem and say, what's the probability of having at least 3 people? At least 3 people. That means 3, 4, it includes 3, right? What's the probability of having having fewer than two people. Fewer than two people is only the probability of 1 and 0. So you would use 1, comma 25 cumulative. So you get only 1 and 0. So you got to be a little careful about the word problem. It's time to finish. We're over time already. Okay. Okay. So guys, this will be posted within a day or two, right? And I'm gonna.